Hi, and welcome to Java 1 Intensive class number 4. Today, our agenda is a little quite packed, so we're going to try to go through it. And so let's get started. Today, we're going to be talking about file organization. We're going to be also talking about basic input and output. We're going to be talking about what is a hash table. We're going to talk about our final project. We're going to talk also about exceptions and the try-catch, how to create your own throwable and understanding the throwables. What is the keyword finally and what is the keyword throws. So let's get started. Packages are nothing else in Java other than a way to organize files or organize your classes. Let's go a little bit more in detail with this. So we're going to create a new class that we're going to call account for our app that we're going to be building. And let's assume that our account is going to be where it's our mobile app, and we're allowed to sign in via multiple ways. We're allowed to sign in via Google, and we are allowing us to register via Facebook. And when you do those things via those services, you are also creating an account in your server. So how do you differentiate between the account from Google, the account from Facebook, and the account from your own app? Well, packaging is a way to namespace and organize files. What is a package? A package is nothing else other than a structure of folders that allows you to prefix things and namespace them correctly to avoid collisions. So in order for us to create a package, we right-click, we go into New Package, and in IntelliJ, we can type the full qualified name of the package. For example, I'm going to use my domain name, which it's typical. You use the reverse TLD. So for example, if we did UCLA, it would be edu.ucla, let's say extension, and then we say Java 1. That's a way of namespacing it and making it pretty much quite universally non-collidable. But if we reveal it in the Finder, we can see that here we created a few different data structures. Like the way things are here as edu.ucla, it's nothing else other than edu subfolder UCLA, subfolder extension, subfolder Java 1. So in here, we can now start placing our class. So what we can do is either we create it there or we drag it there. And voila, this thing that describes the package that it's living in appears now in the source code of the file. Again, this is all just essentially a tree structure. If we go again to our source folder, if we see it's just a tree structure where we can, add more. Let's assume that I want to create the Java 2 folder would be the Java 2 package. And now when it refreshes here, now I have Java 1 and Java 2. This allows us again to make sure that we do not collide with other classes like this example right here. This is basically reiterating that. So packages, whenever we're shipping something, and let's assume that I am going to build this. When we build something like this, let's do like main. And once we build this, you are going to see inside of the project this out directory. And that out directory basically is where the class file is going to go. That is only on IntelliJ. If I wanted to package this guy, I could compress it into a zip file and make it a jar file. And a jar file stands for Java Archive. Just to maybe explain a little bit what are jar files, an example of something that is written in Java, which is this database that it's becoming really popular now, that it's called Neo4j. We can download, let's say, APOC jar Neo4j. That is for the special operations that you can add to the database. And this is basically how some of their plugins are written. And you can download those plugins for your own usage. So if for example, if I'm going to download the 3.5, which is the one that I'm using, I can download this APOC jar, and it's 15 megabytes of compiled stuff in here. If we wanted to understand what is in that file, so if we did the jar file, if we want to list the contents, we go -tvf and we pass the file, and that's going to tell us what are all the files and the organization inside of all of those. So you can see that there's plenty of packages here, and then the token factory class, for example, is in the org antler v4 runtime, and there's plenty of classes in here. If we also went and say like into the IntelliJ directory and say we opened up IntelliJ, you can see that there's plenty of jars in here. That essentially is how we ship the full package of the application that we are working on. That is basically the dual purposes of jars and packages, just to make sure that we can ship things as one single thing rather than individually all these little files to our users. One thing to be conscious about packages is that whenever we're using them, let's create another file here, like let's say intro. And in this intro, we add our main class, and we wanted to start using, I don't know, import java, java.sql.connection.start. Let's just see. When we do something like this, we are bringing the entire scope of that library, of that package, into our program. So now we can start saying like connection, and you can see like if I did C, you can see that a bunch of different things from the Java lang and Java util, because that's the one that IntelliJ tries to add, but in reality it's only whatever it's here plus Java lang. Now we can see like even driver, all the stuff from Java SQL. So it could be importing a lot of things or bringing a lot of things to like in context. So what I'm going to do here is that I could, I don't know, just like say the driver, just importing what I need. And that's the actual purpose of this slide that I have here, because you don't have to bring everything in the kitchen sink. I just had one single image to help you remember that only bring what you need, don't bring everything into the scope. The next thing that I want to talk to you guys about is about basic input and output. Basic input and output is just something that how we get data into the program and how we write data out of the program. Actually, any program that we have, even say in a Mac or on Windows, whenever we're calling this, essentially a command line program is executing. So for example, if I do PS, which is a command for checking out what are the processes that are available or open, you can see that, for example, I have Chrome open. You can see all the different processes and sub-processes that Chrome opened. Maybe because I also have QuickTime, we can see for Quick, you can see all the 2 processes that I've got running with QuickTime. Every time that you're executing a program in the POSIX operating systems, you have, because this is legacy stuff from when computers were pretty much brand new. In a program, when you are executing it, you need basically in the very, very, very early days of the computer, we had only a keyboard to input data into the program, and we call that standard in. That's basically whenever we type something into the keyboard, it makes it into the program. Then a program also has this file. It's basically a file, the way that the Unix operating system considers it. And in order for it to write stuff to the screen, we also had standard out. And standard out is basically whatever you want a program to write in here. But sometimes programs also have issues. Even if we go into like console, we can see that there's all sorts of things that the computer might write to and might actually scare the user if we were going to see it. So for example, DNS service query record. Like imagine using a computer that it's just sending you all sorts of Bluetooth or things like that that are actually sending events for them to be analyzed later by the developer. So in order for us to not saturate the output that a user would have, the computer would start to push information that was intended for saving that information into standard error. When we see that we have standard in for input, standard output for traditional output, but standard error for sending extra messages to the system. How did Java deal with standard input and standard error? Well, it's very simple. It's considered, they're again considered files, but system.out, which you've been using for a while, it is essentially standard. This is standard error. Standard out, sorry. If we did the same thing, but use system.err, and this is the standard error. So if we ran the tool, you can see that how the standard out is written in black. And because IntelliJ is executing this program, it tells us to print that error into the same output, but it's coloring it red. If we were going to call this program, let's say, let's open in terminal. And if we are in Java 1 int and we run Java intro class, it's just intro because you don't need to pass that. And I told via Unix to suppress the standard error output. This is just a Unix directive to do that. You can see that the standard error line went away. So again, program mostly deals with the input and output of standard input, standard error, and standard output. That doesn't mean that other programs don't have other mechanisms of input, like for example, a mouse, a touch screen, things like that. A pen, virtual reality devices. Those are other ways of trying to get the traditional input. But by default, the operating system assigns the standard input, standard output, and standard error to each process. So we've talked about the outputs. Now let's talk about the inputs. So we can do system.in, and that is an input stream, but an input stream doesn't become really useful if we don't have a way to explore it or manage it. So the easiest way that I want you guys to remember how to capture information from the command line is by using a class called a scanner. And I'm going to delete this thing. A scanner is a utility in Java that allows us to transform data or to scan data to keep looking for data until a pattern is met. For example, let's try to read a line, meaning we're going to be pressing a bunch of keys on our keyboard till we hit enter. So if we do scanner in or scan, and we do new scanner, and we put system.in, that's our scanner. So we can then now do scan.readline, next line, that's the one that we're going to do. And we can put it as a string, line equals. And before I do this, I'm going to put a system out just to say enter your name. And then afterwards, I'm going to put a hello, comma, line. In short, this program, when we run it, is going to ask me for my name. So I'm going to put Juan Carlos. And it can be scanning the command line until it hears the enter key. That is because the next line it's doing that. But what happens if I'm trying to get some other thing? Like for example, what is your age? This is something that is really cool about the scanner, because we can say next int, and it will help us to age. Boy, you are old at age. So if we did the same thing, and now because this thing is expecting an int, we put text, we're gonna get an input mismatch exception because this is expecting an integer. So again, if I load it now with a proper int and I say I am 25, which clearly I am, you can say that the program tells us that, boy, you are old at 25. So the scanner is a great way to capture data coming in from standard in. It just makes it simple. It makes it easy. It makes you guarantee that if you want an int, you're going to get an int. If you want a long, you're going to get a long. If you want a full line of text, you're going to get that line of text. What if we wanted to read and write from a file? What I'm going to do here is that I'm going to read the same source file that of my intro class. So I could use also the scanner for reading those files. So what I'm going to do is that I'm going to put a file reader, and we're going to call it file reader equals new file reader, and we're going to put intro dot Java. And there's a chance that this file is not going to be found. So this guy is telling me that if I look at the exception that he's saying is that there's an unhandled exception of file not found. So what I can do is Alt Enter, and I'm going to surround this with a try catch. Then in that same try catch, because I need in this block the file reader to be available, I can do scan equals new file reader, new scanner, sorry. And we're gonna pass a file reader to it. So I can do now a while scan dot has next line. I can use scan dot next line, and I can just print this, like let's say system dot out dot println. And actually what I want is to tell me how many characters are per line. So string line equals scan dot line, and then I'm gonna do line plus, and I'm gonna concatenate it, adding 3 dots, and actually let's string dot format it's %d. Okay, so we're gonna say that line dot length. So now I'm going to print the source of this same thing, and it's gonna print, for example, for this, it's going to have 38. Then for this, I'm looking at this 27, etc. So if I run it, you can see that it's saying 37, 26, 25. It's pointing the amount of characters that are in that file. In each line of the file. Here I am using the scanner as a way to do that. Now let's assume that we want to save this same thing. And actually, let's even put a counter, int count equals 0. And then we do count equals count plus plus. And we're going to also put it in the same format where we have count, the line count, and the line length. So just to, follow the same format where it's like 037, 126, etc. So it's printing the amount of lines. Actually, let's start at 1 because counters are great for computers, but people, when they read this, it's like, why it's 0 rather than 1? It's the first line. So now it's actually doing that correctly. Okay, so let's try then to save all this information. And actually, let's put this as %s. %s, %d, and all those are very similar to the date formatting things, where there are certain types of characters, or when you're using a string format. So let's change this string format into string output or outline. it's going to say, okay, first put a string, then dot dot space dot 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 space, then another digit, and then another digit. And then afterwards, it's all the arguments that it's expecting. So for example, the percentage S has to be the first argument. The percentage D has to be the second argument. And the last percentage D is this. So we have formatted the output that we're trying to use. So I'm going to use another file pointer, file writer, f out equals new file writer. And I'm using a similar structure, and rather than file reader, I'm using a file writer. And then we're going to save it into intro.java account. I'm adding its own fake exception. And in this case, it's expecting that there could be an IO exception that I cannot write to the file, for example, or permissions. So what I'm going to do is that I'm going to change this to exception right now, just as a general thing, so that way I don't have to confuse you. And we'll review exceptions in a little bit. Now that we're creating that, we can do like, we can write into that file our output line. And then at the very end, we can do fout.close. So that's opening the file, writing to the file whatever we created, and then an output to close it. So we are going to see that now we created this intro.java account, and it has those, but as a single line. So why don't we try to change this, and so that way we write a new line. Maybe we need to add a new line in here, like this. \n is a special character in a string that tells you that you're writing a new line. So now, if we open up our Java account, we can see our code with the proper markers that we added, the ... 137, 226, 226, etc.